Okay, welcome back to the next video. So we're carrying on then on our topic here of particle model of matter, and this is actually the first in a series of probably 3 videos really that covers sort of a main section of this topic, and it's all to do with something called internal energy. And so internal energy is the title of this video, and what I want to do in this video is introduce to you what internal energy is, and then go through kind of what it means in terms of when we're heating up and cooling down substances, and that will become clearer as we go through. Okay, so let's look at a definition for internal energy. I mean, essentially, internal energy is just the energy stored within a material, but that's not really enough detail. People often put that in exams and it doesn't get them the marks because it's just not detailed enough. So let's think about where is the energy being stored in a material. A material, by definition, will store energy inside it. Where is it being stored? Well, it's the energy of the particles. The particles inside any object, any system, have got energy. They're moving, so in a solid they're vibrating, in a gas you know they're moving around a lot more. So if they're moving, they've got kinetic energy. They've also got potential energy. You think about it, particles have bonds between them, bonds or forces between them, and you can almost think of them like little springs holding the particles together. So say in a solid, you've got particles held together by what are effectively little springs, and they're not actually springs, but you can think of them like that. They're the bonds, they're vibrating, the particles, and imagine in a spring you store elastic potential energy. So these bonds are actually, it's a store of potential energy. So those particles have got both kinetic energy and potential energy, and the total kinetic and potential energy is what we call the internal energy. Okay, so for our definition then, this is what we're going to write down, and it's really important that you get this down into your notes. This is a very, very common one to come up in exams, by the way, a definition for this. So the internal energy of a system, and that word system, if you can't remember, just write it down, just means object or group of objects. So the internal energy of a system is the total kinetic energy and potential energy of all of the particles. And I will just clarify, in chemistry you learn about atoms and molecules. These are not different particles here, okay? These particles are just the atoms or molecules. Okay, we just use the word particle as a general term. That make up the system. Now that's the full definition, and that is definitely one to learn. Because, as I say, it comes up quite a lot, and if you can remember that definition, that's then some nice easy marks. Okay, so let's look at this then in a little bit more detail. We've talked about the kinetic energy there being to do with particles moving. We've got the potential energy to do with the bonds that are holding the particles together. Now what I'm going to actually do here is do a little bit of colour coding, and you may well want to do the same in your notes with highlighters or with underlining like I'm going to do. And I'm going to keep this colour coding consistent all the way through this video. So we can talk about the kinetic energy, and I'm going to underline that there in red, and the potential energy I'm going to underline there in green, and we will come back to those colours a little bit later on. Okay, what I want us to think about then, and it's all along the same lines, I want to think about what actually happens to the temperature of an object as I heat it up. Okay, and what we're going to do, we're going to draw a little graph that shows how the temperature of an object changes as we heat it up. And by heat it up, I mean put energy in. So let's have a look. Okay, you can see I've got my axes here, and so I'm going to have temperature here on the y-axis. Now I don't need to put units on because it's just a sketch graph, but obviously if you're actually plotting it you would. And then I've got time here on the x-axis. So temperature on the y-axis, time on the x-axis. And this is showing as we heat up So as we heat an object, okay, or a system, I suppose, as we heat up a system. So by heat up, as I said, I mean I'm putting energy in. Now, let's imagine we start off and our object is a solid. If I start to heat up that solid, I start to put energy in. For example, I put it over a Bunsen burner, I put it in an oven. You know what is going to happen. This is not rocket science here. The temperature is going to increase, okay? And so we get an increase in the temperature. And eventually, if I have a solid, you know that eventually that solid will start to melt. For example, if I had ice, once that gets to 0 degrees C, it's going to melt. And there is something slightly strange about this, because when an object actually is changing state, so it's going from, say, a solid into a liquid, its temperature actually stays the same. Ice melts at 0 degrees C. So any ice that is melting will be at 0 degrees C. And that's a little bit weird. So what our graph is going to do now is we're going to have a flat bit. That's strange, because that means that we're still putting energy in, we're still heating it up, but the temperature stays the same. Eventually though, as we know, all of our ice, say, will melt, it'll all become water, and then the temperature of that water will start to go up until our liquid, our water, turns into a gas. And again, while it is turning into a gas, while it is actually boiling, I will use a ruler for that. I should probably have used a ruler for that last one, really. Its temperature stays the same. And then temperature will carry on going up once it is all boiled. Okay, now let's put some labels onto here. Okay, so this bit was when it's a solid. This bit here is when it's a liquid. And this bit here is when our material was a gas. Okay, and then obviously we could label our changes of state in between. So this here, this is when it is melting, because it's changing from a solid into a liquid. And this here is when it's boiling, so it's when our material is changing from a liquid into a gas. Okay, now from that graph, actually, if you had this graph for real material, you'd be able to find the boiling point and the melting point. Look, there, that there, that's the melting point. Okay, you can see that's the temperature where our material melts. And over here, I will use a ruler again. Okay, that's going to tell me my boiling point. So if I'd drawn this for water, if I actually did this experiment with water, and I found the temperature as we heat up water or ice into water, you'd find that this flat bit here would be 0, this flat bit here would be 100 degrees C. Okay, now, that's all very well. You probably actually saw something similar to that lower down the school in Key Stage 3. But let's now think about what's actually happening. Okay, going back to our definition of internal energy. Well, one key thing, all the time through the whole of this, okay, internal energy is increasing. Right, if you are heating it up, you're putting energy in, okay, that object is gaining energy, the internal energy must be increasing. I'm sorry that's quite difficult to read, but that's so important. All the way through, the internal energy is increasing. Okay? But there are different sections. Okay? Now we can see here that the temperature is going up. Now the thing about particles that determines the temperature is the kinetic energy, or rather the higher the temperature of an object, the more kinetic energy the particles have. So here, while the temperature is increasing, the kinetic energy of the particles must be increasing. Okay, now we know that internal energy is kinetic and potential energy, so if we increase the kinetic energy of the particles, we're increasing the internal energy. So going back to my colour coding, I'm going to just overlay this here in red, because that's where the temperature is increasing. I'm sorry. This bit here then, again, temperature's increasing. That's where the kinetic energy is going up. And then here again, temperature's increasing. Okay, so if we sort of track through what's going on here, as we heat up our object, the particles are getting more energy. They're moving more because they've got more kinetic energy. So in a solid, the particles start to vibrate more and more and more. until our substance starts to melt. Now, when it's actually melting, the kinetic energy of the particles is not going up. That energy is actually being used instead to weaken the bonds between the particles. And what that is doing is it's increasing the potential energy of the particles. So from my colour coding, I'm going to just overlay this bit here in green. So here, the potential energy of the particles is increasing. Okay, now eventually, our substances all become a liquid, and its temperature starts to go up again because the kinetic energy of those particles is increasing. The particles in the liquid moving more and more. The bonds have all been weakened now. It's a liquid. Particles moving more and more until it starts to boil. And at this point, at its boiling point, we actually use that energy that we're putting in to break the bonds, or rather, they're very, very weak, the bonds in a gas. And again, once all of our liquids turned into a gas, then the kinetic energy of those particles starts to increase again. Okay, so hopefully the colour coding there makes it quite clear. The red bits are where the kinetic energy of the particles are going up. The green bits is where the potential energy of the particles is going up. But remember, because the internal energy is the total kinetic and potential energies, all of the way through this, the internal energy is going up. If you are heating up a material, there's energy going into it, so the internal energy must be going up. Okay, right. Now what we're going to do kind of over the next couple of videos is look at the red sections and the green sections of this graph in much more detail, because there are formulas and concepts involved to work out kind of how much the temperature is going up by for a certain amount of energy and so on. Okay, that will be the next couple of videos, so we'll finish this video just with a quick summary. Okay, quick summary then to finish. So we're just going to summarise what we've just drawn, really. Okay, so let's say that if you heat an object or a system, remember system just the scientific word for object or group of objects. You increase the energy of the particles, in other words, the internal energy. And this can have two effects. First thing it can do then, and I'm doing it in red on purpose, it can increase the temperature of the object. Okay, so that increases, and I'm going to use EK for kinetic energy, remembering back to the energy topic, so increases kinetic energy of the particles. Or, number two, the second option there, two, it can change the state of the object. Remember, that is because it increases the potential energy, so we use EP for potential energy of the particles. Okay, so hopefully that summarises kind of where we're up to then, in terms of what we've got so far. Internal energy, that's kinetic and potential energies. You put energy into a system by heating it up. You can either increase the temperature or you can change the state depending on whether it's kinetic or potential energies that get changed. And these are going to be the topics then of the next two videos. So next video, we'll look at this top bit, and then the video after that, we'll look at this bottom bit. Okay, hope that all makes sense to you. I will see you then very soon on the next video.